Hello everyone, I am Krish and I am part of this enterprise for 7+ years now, working as a technical architect. I would like to welcome all of you to this third edition of our Tech Meetup. Today we are all here for a very interesting discussion about event sourcing, IAsyncEnumerable and Cancellation Token. I am sure all of you must be excited and are eagerly waiting to hear our speakers. Below we start the tech meetup today. So before we start the tech meetup today, I would like to give you a quick brief about Ist Enterprise. Ist Enterprise is an IT service company specialized in crafting software solutions for startups, small and medium enterprises. With an agile, ready, dynamic workforce of 350 plus technology artists, creating value in all directions. Ist Enterprise helps 100 plus clients across Europe in creating software solutions that are robust, creative, modern, user centric, logical, and secured. Working with Ist Enterprise, change becomes the most dynamic, powerful source of progress, and the heart and soul of Ist Enterprise is its people. So that's a quick intro about our organization in a nutshell. You can visit www.istenterprise.com to know more about it. Now, I would like to quickly introduce you to our essential speakers for today and run you through the agenda of this meetup. First, we have James Lloyd. He is the development lead from Netherlands with around 20+ years of experience in IT industry and will be addressing on the topic event sourcing today. Second, we have Tejas Kumbhar. He is a senior software engineer from India with around 7+ years of experience in IT industry and he will be taking about IAsyncEnumerable and Cancellation Token. Before I hand over the stage to the speaker, few quick housekeeping rules for all of you present here today. In case anyone faces any issues, please feel free to post it in the chat and our team will reach out to you to fix the same. In case of any queries, please don't hesitate to put the same in the comments section and our speakers will try to answer the same during our question answer round. We'll be having question answer session for 10 minutes after each talk. And at the end of the meetup, request you all to provide your valuable feedback as it would really help us to give you a better experience in our future tech meetups. Feedback form link is already shared in the description and it will be also shared in the chat as well. So now I would like to welcome you to our first speakers, James Lloyd. So hi James.
Hi, Krish.
Hi. So it's all yours, James. All yours. I wish you all the best.
Yeah, thanks. Yeah, thanks for having me. It's a nice opportunity to be able to talk about what we've been working on for the past couple of months. Yeah, I won't go into me just now. We'll go to the next slide if possible. Yeah, so today's talk, a beginner's guide to event sourcing. Now, this is my about slide. As mentioned earlier, I've been in the industry for quite a while now, 20 years. During that time, I've really made a career of beginning things. So I began kind of doing C++, user interface and video. I did a lot of architecture in that situation. Then I got interested in CI. And so I began a continuous integration and general build engineering efforts at one of my previous companies, which then naturally led into building and starting on test automation, because once you're doing CI, it's not just enough to be building your software. You have to also test it and make sure that it's working correctly as you build it that quick. And kind of after that, I started looking into this agile leadership and coaching. So throughout my career, I've been beginning things. I don't want it to sound like I'm not finishing them. I did in many occasions. But yeah, always keen to start on the new thing. The goals of this talk, mostly I'm going to try and give you my initial impressions of event sourcing. Event sourcing is kind of a pretty new architectural pattern. I think it's been present for a long time. in one form or another. But if you go out and try to look at it out there right now, there's not a lot of documentation. It's not that common. It's quite complex, I think. But I'm going to give you how I started with it, and maybe that'll help you looking into starting with it as well. I'm not going to pretend that I'm an expert in this. It's something that I've only been really looking back at over the past 6 months or so. I'm also going to not sell it as the solution to everything, because it's not. It's providing a lot of benefit for us in our domain, which maybe I should have mentioned on the previous slide, is doing something rather like this. So giving an online seminar on stuff, we add in a lot of extra functionality while you're giving a seminar. So things like polls and slides built in, and then recording and a whole lot of stuff. And for us, it feels like a good fit because we're very event driven. So we're always looking at things happening asynchronous and real time, and then replaying. It's all good stuff for us. Yeah, so if we could go to the next slide. So you all know this is the very simplified model of a CRUD-based application. So, and I'm choosing to really keep it simple as like a single page application, talking to an API, which is mostly just writing to a database, and the business logic kind of lives in the app. Yeah. If we were to take that and then add in event sourcing, what event sourcing adds is this idea of, instead of updating the state directly, you're storing the updates and then projecting those updates in order to be able to infer state from those events. I've given you this as a quick overview in terms of how it's going to end up, and I've particularly emphasized the read model and the write model. Kind of, it's not exactly the same as what we're using. So I've simplified things a bit, in particular the projection stuff. And what this diagram here is showing is the fact that we're able to add on components that also respond to events being written to the write model, and then respond with their own events. So you end up with this pattern, they call it event symphonies, something like this. I forget the exact terminology, as opposed to orchestration. So is there anything else I need to really emphasize on this? Yeah, the problem with doing an online presentation is I can't see whether you guys have a look of confusion on your face or not. Normally I would dive in a bit more if I could see that this isn't so obvious. I hope it is. What we're going to look at next is the actual projection. So this is really the core of event sourcing. It's something that I think is somewhat glossed over when you come into the pattern and reading about the pattern. But what it is that this event stream, this is your authoritative source of data, right? This is facts about your domain. And when you record these facts and the changes to them, right? So these changes are usually in response to specific user intents and mutations. We record all of that, and then we project it in order to get the current state. If we can go back to the previous slide, so the system one. So what this means is that, so on this this connection between the event store and the database, this project is taking an event and doing the actual update. So that's kind of the familiar sort of thing that you might have seen in your normal CRUD-based application, except it's a fact by this point. So you update your state based on the events that occurred. So if we keep on going through, I have an example that I hope will maybe make it a bit more clearer. So this is an actual example that we covered, last sprint. So this idea of polling in the seminar where you ask for feedback, like engage with the audience. Do you like option A more than option B? Yeah. And if we go through, as we go through the slides here, in one sort of way, it is events occurring over time. In another way, you can look at it as replaying those events to get state. So both of those are projections. So it's kind of a bit like PubSub, and you're responding to events as they occur, and it's kind of another stream processing. Yeah. So if we could start from the top, I'll just walk through and I'll explain what's happening. So go back 2 slides, I think. Oh, too far. Back to the beginning of the example. Yes, this one. So the seminar, the seminar broadcaster, so in our system, this is the main host of the application, starts a poll, which we say is opening, with 2 options, A and B. So as you can see, that would be then projected onto our read database as this document. So something like Mongo, right? So we have an ID for this particular poll. We have the votes that are occurring, which is currently 0 because nobody's been able to vote in it because it's only just opened. Yeah. So it opens up this viewer A. I thought I renumbered these anyway. So viewer A votes for option B. So we take that event and then we update the document. Yeah. And then the next event, viewer B votes for option A. So then we update that field in the votes part of the document. And at the same time, I kind of didn't say this, it's also updating this total votes, right? This is something that maybe you would do in your app upon read previously, but here we're pre-calculating it. Yeah. Viewer A changes their vote to A. So if we take one option away from, or one vote away from B and add it to A, but the total votes don't change. And then the final one is that the broadcaster closes the poll, and then we update the status to close. Keen-eyed people might have noticed, sorry, stay on the other slide, might have noticed the fact that when we say changed the vote from B to A, this requires some extra information, right? Because if you just look at that single vote, you can't tell that viewer A, like the information on just point 4, is not enough to say what was A's old vote, right? And in this case, what we would do when we receive this event, we would probably say, well, we've got to look at all of the previous events and see, well, what options did A vote for in the past, or is this a new vote? Yeah. And then we're able to take one vote away from option B and move it to A. Yeah. So that's an example of having to project the state through these events and infer what viewer A's vote was so that we can then correctly emit an event and project properly. Yeah. Okay. So kind of halfway through, which is good. I'm on time. Some of the good stuff that I've really enjoyed working with this architectural pattern is, as we've seen, CQRS by default. What this means is the fact that you can, it's a common pattern, CQRS, but basically in a nutshell, most systems writes and reads are asymmetric in volume and performance, right? And when you separate them, you have these options to scale each one independently. Yeah. And so for us, what that means is that we get to optimize our event store kind of independently of our Mongo database. Another thing that you might have, I glossed over a little bit on the previous slide, was this separation of concerns between domain events and the view of them. So if we look at this, let's say we want another view of these same events. These events have occurred like by this point. They're already in the database. It's writable. We don't modify it. We don't ever hack on the database. These are facts. But we decide we want to look at them in a different way. We want to interpret them differently. Let's say instead of having just a raw number, like like two options were on option A, instead we want to express it as percentages. Yeah. So we can go and write that different projection, produce a different view without having to, we have to reprocess, but we don't have to worry about the events themselves. Those events stay static. And indeed, we can basically throw out those views that we generated and regenerate them. If we had to, let's say catastrophic Mongo failure, we can regenerate it from that sequence of events. And in this way, we kind of arrive at this third point, is that we can kind of really take what happens in the system and express a view on that any which way we want, so that we can change how the shape is, how we render that data, how we view that data in any way that makes sense based on how we want to display it. Not on how it got written, but just how we want to display it. I'm sure you guys can see how that would be invaluable, right? So you get to write optimized UIs that can just read effectively statically computed data very efficiently. And kind of another artifact that's been really handy is this idea of like having the sequence of events to answer the question, how did we end up in this state? Usually people are presenting this as an auditing thing. So you can imagine a situation where, let's say you were voting on something a bit more material than just whether you like A's or B's. Say you were voting on a candidate or a decision or something like this, right? Something that mattered, right? And it's much harder to fake a series of events than to simply update a database field. If you go and look at Greg Young's work, he has a very good example around horse racing and detecting fraud in horse races, because internal fraud, right? So this is someone with administrator access changing fields in the database. And he, because of event sourcing and the fact that it's an immutable record, they were able to figure this out and charge the guy. We're not at that level. Mostly for us, having this sequence of events allows us to really reason about straight transitions. It's kind of like a log, right? So it's a self-generating log, and you're able to kind of view how your system morphs through time, and you go, oh, see, that event's wrong, that shouldn't have been triggered. And then we can take that and actually feed it into a test to reproduce behavior. So the tests themselves also end up being a lot simpler, in the sense that these are your input events, expect these output events, or these are your input API calls, expect these events. So it's quite an interesting way of debugging that ends up being quite clear. So if we go to the next slide, we get to the challenges. So these are the things that I would warn people about before you get too deep in on event sourcing. The biggest one is you have to break your old habits of really focusing on state first and instead focus on events first. For me, because I've always worked in sort of more real-time systems, so stream processing for video, UI, all of these sort of things. I'm very much more used to thinking in terms of events as a way of orchestrating behavior. But if you're used to more concentrating on modeling data, then you're going to have a harder time thinking in terms of events. But it can be done. There's a lot of techniques out there. One that we applied quite successfully, albeit inconsistently, is this idea of event storming, where you basically focus on all of the events that can happen in your system. You get a nice timeline, and then it's mostly about mapping transitions through these things. So that's really good. I have a bit long list of links at the end of the presentation for you. I probably should have added that one, but it's a really good technique. If we go to the next slide, the next one is not specific to event sourcing, but by nature you run into it anyway, is this event-driven CQRS separation complicates front-end interactions. So there are ways to work around this so that you can kind of hide the asynchronous nature of the events occurring on the back end. But ultimately, you probably don't want to do it. And so that means that it's not as simple as just posting your data and reading back your the results of that post, say, like when you create something. On top of that, so kind of related to all of those, is that just designing is a lot harder. There's a lot of different design considerations that you have to add in. Probably the biggest one is idempotency. This affects most messaging platforms. Being able to take an event and process it or not process it, and realize when you've already applied the event. It's something that you've always got to keep in your mind, and really varies based on how you structure events. Another one is eventual consistency. Again, not specific to event sourcing, but happens because of event sourcing if you choose it. Like I said, you can't instantly read your writes. So when you create something, it doesn't mean that it's there to read in the database yet. So you need to design around that. And probably the one that is actually very specific to event sourcing is really designing how you organize your events into streams and substreams. This really affects your ability to project the events. And just remember, you actually want to be wanting to project those events all the time, because they're the authoritative state of your system. Not these views that you generate, but these events. And designing these correctly, and then adding in other optimization strategies like caching is really the core of getting your system right. So you want things that are short to project, that have kind of organized so that they can be self-consistent with each other. These are the things that you really need to think about when you're designing your event-sourced system. There are other ones. These are the big ones. I'll leave those for you to find out if you decide to go down this road. These are some of the most important links that I found while I was getting into event sourcing. The number one is Event Store. So Event Store is this custom-built event sourcing database. So it's a database that is optimized for this write and read style, write and project style that event sourcing has. It has a nice server. It has a nice view. Its .NET client is quite good, though I have found a bug in it. But it's actively worked on and supported by Event Store. The next couple of links are a couple of things about the actual pattern itself. So from both Microsoft and Martin Fowler, who's quite a big thinker in this area. There's this CQS journey, which I found really interesting. So even though it's labeled as CQRS, it also mixes in a lot of event sourcing and domain-driven design, which is something else you will encounter a lot. I do want to say, so a lot of the event sourcing stuff is presented using domain-driven design terminology. but I don't believe it's something required. So I haven't addressed it in this talk, but be aware that it's going to be out there, and you'll meet it when you're going through this stuff. Then the last couple are a couple of the big libraries that I found out there that can support you. We didn't start off with libraries. We rolled our own. That comes with its own set of problems. We do evaluate, and we're actually looking at this last entry on the list of Eventuous to replace our custom rolled one, just so that we can kind of focus more on building the event sourcing rather than building the event sourcing framework. It seems interesting and promising. Yeah, I think, is that my last slide? Yes, conclusions. Conclusions with my short experience, albeit experienced viewpoint, it is a very good fit for event-driven systems. So if you're already doing stuff that deals with a lot of events, or being able to replay events or look back at in time on things, it's really great. It really fits the domain well. And it comes with a lot of benefits, particularly being able to go back in time and render stuff differently, all this other things. It's hard though. So there's a lot of structuring, a lot of maybe extra stuff, a lot of potentially duplication as you move, as different parts of the system have the same views, well, need to use the same views of things differently. Yeah. I think probably start with a framework. That's going to give you a taste of what it is, but ultimately the frameworks themselves have a very limited viewpoint on event sourcing. That might mean that you miss out on a lot of the benefits. And so my final advice is, maybe don't do what we did. Don't go all in on event sourcing from the get-go. Look at the parts of your system where it makes sense, where you're already writing events, where you care about this sort of stuff, and put it in there selectively. And then build it up. It's not an all or nothing thing with event sourcing. You can isolate stuff. And like I really tried to do with that initial event sourcing presentation, you can see how it's like it's just a different channel, right, for maintaining those read views that you're more familiar with. Yeah. If you decide to go down this path, best of luck. Feel free to contact me if you do. I'd love to hear about it.
Thank you, James, for this wonderful talk. It's quite interesting, and I'm sure the audience loved it as well. We'll quickly move to the question answer section and try to answer some of the queries our audience has. So one of the queries, James, our audience has is like, how does inconsistency or instability in network affect the queue of events getting lined up, and how it's handled?
Yeah, so it has a more of a reliable way of viewing this, right? So because events, so in the terminology of a normal messaging system, like something like Kafka, right? So I think Kafka has some limited ability to retain events over a certain amount of time, and that's how they deal with network inconsistency. Event store, it's there all the time, and you can start off, you can go, like, have your network go away for minutes, hours even, or even something that they're talking about now is occasionally connected components or microservices, so that the events can pile up and this component can come online and reprocess them way after they've been emitted. So that is actually another really good benefit of event sourcing, is this resiliency in the face of network failure.
All right, thanks, James. So it's one of our, like, so then one question is, James, like, okay, how is it different from event driven? Like there is event sourcing and then event driven. So how is it different?
It's the awesome bit. Sorry, I don't mean to be a bit flippant about it, but it is really you're not just you're not just being driven by events, right? It is really um, you source your data from the events. So this is the crucial point: is the fact that um, your source of truth is this list of changes that happen to your system. It's not the projection that you have, right? So that thing that I showed you earlier about the poll stuff, um, the nice familiar document on the side is not the truth, right? That in fact you should view that as the temporary bar, right? The bit that can be thrown away. I mean, we don't do it in practice because when you have really long streams and a lot of events, it can be very costly to reconstruct those views. But the key point is those events, those mutations to your domain are the truth. But
Okay.
like real truth, you can reinterpret it, right?
Hmm. True. Okay. Okay. Then is there any use case like there is one person is already from Muhammad Khalid is asking like is there any use case or challenge that you find it challenging and for which event source can be a useful scenario.
Um, okay, so if I understand correctly, it's like what technical challenges I see that event sourcing is the correct fit for.
Yeah, something like that
Yeah.
maybe.
Okay. So, like I said, it's really if you're already doing events, right?
Hmm.
This gives you the ability to really store those events as if it was a log and generate views out of it, right? That is really the so for us, right? The thing that we really look forward to leveraging event sourcing for is um, generating new reports about seminars that happened 6, 7 months ago, right? Because the facts of the seminar didn't change, right? But
Hmm.
maybe how we look at those events occurring did, right?
Yeah.
Maybe we didn't 6 months ago really care about people joining and leaving the seminar, right? And we
Okay.
never really we didn't build views for that.
Okay.
But business requirements change. We want to understand when do people join, how long did they stay. We want to give this report to our customers because they'll pay nice money for it. And so we don't have to just deal with the seminars that are occurring now. We can go back in time and say, well, these reports look like this for this seminar that you gave 4 months ago, right?
Hmm.
So
Okay.
that's the sort of advantage that I could really see event sourcing being a great fit for,
All
and
right.
something that you can't really accomplish with other systems. I suppose maybe a data lake where you're just collecting data in the hope that it'll be useful one day. Something like that, maybe, where you just collect all data by default. But I mean, event sourcing is kind of that as well.
Okay, okay. Thank you, James. And I think Shashikant Pawar is also, helping with some of the information, like
Yeah.
event-driven architecture. In event-driven architecture, event goals is to use for communication. So we store them basically, and then in event sourcing, basically, event is source of truth, which needs to be sourced. So he's giving some, useful information probably for
Yes,
you as well. Yeah,
Shashi's my right hand guy in the team
great.
at the moment,
Okay,
implementing this. So
okay.
yeah,
All right. All right, clear. Thanks. Thank you, James. So yeah, James, thank you for this session and thank you for answering the questions so far. And in case anyone has any more questions, please feel free to put it in the chat, and we'll surely answer maybe in the last session as well, last section as well. So yeah, thank you, James, for your time. And yeah,
great.
we'll
Thank
get
you.
back again at the end of this meetup. Yeah,
Awesome. Thanks.
thank you. All right, guys. So moving ahead, I would like to welcome our second speaker, Tejas Kumbhar. So I'm just adding him. Yeah. Hi, Tejas.
Hi, Krish.
Hi. So He will be basically discuss about IAsyncEnumerable and Cancellation Token today. And yeah, Tejas, stage is all yours. Wish you all the best.
Yeah, thank you. First of all, Krish, thanks for giving me this opportunity and a platform where I can share some technical stuff. Yes, so I will just give a quick introduction about myself. So myself, Tejas Kumbhar, and I have more than 7+ years of experience in IT industry, and I've been working with an Eastern enterprise for last more than 3 years. So talking about my technical stacks, so in my initial career, I worked on many technologies like .NET Framework, jQuery, database, SQL Server. But in the past few years, I am mainly focusing on the .NET Core backend side. So today's our topic is more about the cancellation token and IAsyncEnumerable. So about this topic, at the end of this session, you will learn two major things. First is like how IAsyncEnumerable helps to reduce the waiting time of an user. So for example, when a user requests for large data sets, for example, suppose 100 records, so he doesn't need to wait for all 100 records to be loaded and sent back to a user in the front end. So this is IAsyncEnumerable will help you to reduce the waiting time. And second major thing is like how you can handle the wastage of memory resource on the server. Like if ongoing request is cancelled by a user in a front end, so how that request also needs to be cancelled in the backend server or the backend side, so that the memory uses by that request should not be higher side. So going forward in our today's talk, we will learn about what is the IAsyncEnumerable, what are the different approaches prior to the IAsyncEnumerable, and how the IAsyncEnumerable overcomes the advantages provided by those prior approaches. The next thing we will learn about the cancellation token, and the last one will be how the cancellation token can be used with or without the IAsyncEnumerable, and what are the different approaches. So let's talk about a little bit about IAsyncEnumerable. So consider in a given scenario where you are building an application where the application requires a number of simultaneous operations. So you will basically go with async call, but async call also comes out with a little bit of waiting time for an user. As I said earlier, like if a user is requesting for 100 records, so he needs to wait for all those 100 records that needs to be loaded in the front end. So that also provides some blocking operation, or we can say waiting time to an user. And to avoid this, IAsyncEnumerable helps a lot. As its name suggests, it uses the async method as well as the yield keyword. So what is a yield keyword? Many of the .NET developer might be using the yield keyword, which iterates each record and it returns as soon as it gets the data from the server. So it doesn't need to wait for all the data that needs to be loaded and then it will send to the UI. So it doesn't happen in that case. As soon as it receive any one record from the database, it has a tendency to send it to the UI. The third one is IAsyncEnumerable provides the enumerator, where you can avoid the iteration and you can yield each record at a given time. The major drawback of the IAsyncEnumerable is that you cannot return the result as it is in the form of IAsyncEnumerable. You have to mandatory iterate each record and need to send the data in the form of yielding. So let's focus on a given problem statement where in the front end you need to load a chunk of data which requires a high processing time and also involves the high memory uses. So to tackle this problem, we have few options like a synchronous call, where you can have a multiple requests to the backend and each request will be processed independently. Like if there are two requests, so the second request doesn't need to wait for first request to be processed. The second approach will be the yield keyword, where you can yield each item at a time. As soon as you receive a one record from a database, you will directly pass it to the UI. But these two approaches comes with some of the drawbacks that can be covered with IAsyncEnumerable. So let's see with the help of a diagram. In a given scenario, suppose we need to build one page where there are two sections. In our first section, we are loading the list of a user, suppose around 100 and 200 list of users. And the other section is used to display some random details. So there are two requests for two sections. So each section doesn't need to wait for other section to be completed first. So for this purpose, you can have a asynchronous call. Like there is a front end and over here is the back end. So there will be a one asynchronous request to get the list of a user and second asynchronous request to get the other details. So each request doesn't need to wait for other requests to be get completed as it is a asynchronous call. So whichever request get processed earlier in the backend, that will be written as a response to a front end. So suppose the first request took much time than the second request. So the second request was responded earlier than the first one. So this is how the asynchronous call works. So basically, when you're using a asynchronous call, you need to make a sure use of a keyword async, and the return type should always be a task. And in the task, you can just return anything. Over here, we are returning the list of a user in our given example. But again, as I mentioned earlier, asynchronous also come with some drawback. In our not actually a drawback, but if a user have a special kind of requirement where he doesn't want to wait for all the data needs to be loaded in the front end, or he wants some continuous interaction in the front end. So in that scenario, the asynchronous has some drawback. So let's see with some demo. So in my example, I created one controller, a user controller, and one repository. So there is no middle layer I have considered. So directly API talks with repository, just for our demo purpose. So let's focus on first in our case, async call. So in a async call, as I mentioned, we need a async keyword and it should return some task of a result. In our case, we are just focusing on returning the username. So the return type will be a string. And yeah, I created one repository which faces a list of a user directly from the database. So in my case, we just took about 20 records among the 100, and as it is a async call, so you need to just use a to async. And to add some additional processing time or performing some business logic, I am just iterating the each user and fetching the and adding creating a list of a username and returning it to the API layer. So over here, the result will come and it will be returned to the UI. So just to add some performance stuff, I am just writing some console lines. So let's run the first example. So now the API is running. Yeah. So I'm getting the result of user sets through the async call. So you can see over here. So the user are starting loaded in the backend and processed, but nothing is viewed in the front end until and unless all the 20 users are processed. So even though it is a asynchronous call, but still there is a waiting time or waiting processing time for any user to view all the 20 records. So when all the 20 records has been processed, then only we can view the result. So this adds some blocking of the processing time to a user, even though it is a asynchronous call. So to avoid this, we can go with a second approach, that is a yield keyword. As I mentioned, yield keyword is returning a data as soon as it receives from the backend or from the database and process passes to the front end. So, but again, it comes with its own disadvantage that we can see with the demo itself. So in the controller, again, I created one API method for getting the result through yield keyword. So as this is not a asynchronous call, so it's just returning a normal list of username. And at the repository level, the only change is, again, it's returning me a first 20 records. And to add a processing time or business logic, I'm just iterating each user and yielding as soon as I receive one record. And to add some more processing time, I'm just making that thread to sleep for a few seconds. And again, this each record is held to the API. And again, as soon as we get a one single username, again we need to process it through iteration. And again, we are trying to yield it to the UI. So in this scenario, we are trying to fetch one record, one user from a database, and trying to send it to the UI as soon as it has been processed. So to do that, we again need to iterate and yield in the API level also. And I'm displaying the username in the API method so that we are able to see like it has been loaded from a database, and it intentionally it is passed to the API. So to go through this example, I will hit the request which is using the yield keyword. So as you see, the user is being loaded from a database, and it is immediately displayed in the API, but nothing has been updated or nothing has been processed in the front end. The request is still going on. So after all the 20 records has been loaded, it is displayed in the in the UI. To make it better, I can just stop it again. Yeah, I will run. Yes. So now this screen is blank when I request the user through yield keyword. So you can see those are available till the API call, but they are not passed in the front end until and unless all the 20 records has been fetched. So again, similar to the asynchronous call, this yield keyword also providing some processing time, we can say, or the blocking time for any user to view all the 20 records. So this is a disadvantage of an yield keyword, we can say. Like even though the method was synchronous, but it acted as a asynchronous call, but at a certain level only. From the repository level till the web API, it's act as a synchronous call. It was able to yield one record at a time, but when it comes to the API, it's behave as a synchronous call, and that's the disadvantage. Like if a user doesn't want to wait for all 20 records to be displayed, or he wants a single record needs to be displayed at a time. So in such scenarios, it provides a blocking time. So to overcome this, why can't we use the yield keyword with the asynchronous call? Why can't we just mix the features of both asynchronous and yield keyword? So let's try that one. So to make a asynchronous call, I need to change it to async, and each async will have to return the task of some result. But the yield keyword never return a task. It is not applicable to use a task along with the yield keyword. So that's the drawback of using a yield keyword with asynchronous call. So in a C# 8, a new feature was introduced that is known as a IAsync enumerable. So I will just revert those changes. Yeah. So this is the third API which uses the IAsync enumerable. So the syntax is the same. You need to make a call as a asynchronous, and instead of a task of some result, you can directly have a IAsync enumerable of a result type, return type. So as I mentioned in IAsyncEnumerable, you need to await the each iteration, and you need to return the result through the yielding. So each result will be returned to an upper layer or the calling method to the yield. So in the demo, at the repository level, we again created a asynchronous call to a database where you're again taking the first 20 users and you need to make a IAsyncEnumerable. So each record will be loaded, and as I said, it provide the method to await the iteration. So each iteration will be awaited, and you can return the result through the yield keyword. So every time it is mandatory, you need to iterate the response from the IAsyncEnumerable and return it through the yield keyword. So in whichever layer you are using the IAsyncEnumerable, in each layer, every time you need to iterate through await and then return it to the yield keyword. So we are doing the same thing in the web API also. We are getting the list of users in the form of a IAsyncEnumerable. So as I mentioned earlier in the first slide, we cannot return the result as a IAsyncEnumerable. Again, you need to iterate each result and return it through a yield keyword. So over here, also I am displaying the username in the controller level. So we get an idea like it's being loaded from a database and directly passed to the UI level or the API. So again, we will go through a demo. So yeah. So now let's make a third call with the IAsyncEnumerable. So you can see the database call has been made. So as soon as the user started being loaded in the API, it is passed to the front end. So for the user, there is no such waiting time or blocking process time over here. As soon as we got a result from a database, it has been processed and immediately it is sent to the UI. So user doesn't need to wait for all 20 records to be processed in the backend, and then all the list will be sent to the front end at a time. We can just iterate each record and make it visible for an user without making him to wait for all 20 records. So basically, this is the advantage of IAsyncEnumerable. Like it minimizes the waiting time for an user. Our next topic is the cancellation token. So what is the use of a cancellation token basically? So suppose in a given scenario, like where the user is requesting a large number of data, and that request has been made and pass it to the backend for processing, and then user like cancels that request. So that request is basically cancelled at the front end level only, at the browser level. But the processing of the data is still going in the backend, which involves the memory resources or the server resources to process that request. So if a user makes such 20 requests and cancels all the 20 requests, those are cancelled only in the front end, but the backend processing still continues. So to avoid such scenarios or to avoid the wastage of memory resources in the backend, if a given request has been cancelled, in such scenario, the cancellation token comes into picture. So as it is made of a two-word, cancellation and token. So that means the front end needs to send some token to cancel that request. So we will see this also with an example. So yeah, I can rerun the API. So yeah, first we will see without using a cancellation token. So what exactly happening in the front end and the back end. So this is a asynchronous call without a cancellation token. Again, it's returning the sets of a user with a username. Again, at a repository level, we are just fetching a list of a user, and to avoid to add up some business logic or processing time, we are just iterating the list of a users and making a thread to sleep for few seconds, and then that result is passed to the API and then to the front end. So let's hit that request without using a cancellation token. So you can see the backend side, the list of the users are start getting processed, but when I cancel the request in the front end, so nothing has been canceled in the backend. Still, those 20 records will be processed in the backend, and which involves the wastage of a memory at the backend side. So even these 20 records has been returned to the UI, but that request was cancelled from the browser. So it's not going to process anything, or it's not going to display anything in the UI, but that was still able to process in the backend. So this includes the wastage of a memory resources. And suppose your request involves a huge data. So at that time, the memory allocation will be very high. So to avoid such scenario, we go with a cancellation token. So I already created another API which includes the cancellation token as a parameter. So again, it's a sync call, and we are using, so we can use the cancellation token with or without the IAsyncEnumerable. So over here, I'm making a use of an IAsyncEnumerable, and in a parameter, we are passing a cancellation token. So you don't need to consider this parameter while requesting the data from the API. So you don't need to manually pass this cancellation token. It will be taken care by the browser or any front-end technology, like you can say Angular or React, where you can make a observable to cancel that request. So this token will be automatically set through the front-end technology, or in our case, when you are directly working with the API, that token will be initiated by the browser itself. So you don't need to pass in the URL as a parameter. So this cancellation token I'm setting through some dependency injection. We will talk about it later. So our main goal is to just fetch the list of a user. So again, at the repository level, as we are making the use of a IAsyncEnumerable at a database level, we are going to cancel the request. So through the DB context, we are requesting the user, and to make it work at a database level, you need to use the extension as a IAsyncEnumerable, which further will provide with the extension method with a cancellation. And with a cancellation, you can actually pass that token, which we have set it in the API level. So basically, this has been used to cancel the ongoing request at a database or the server side. So like you requested the 100 records, and in meanwhile 10 records has been loaded, but then again the user cancels the request. So after processing those 10 records at a database level side, that request will be cancelled. And again, as you are working with the IAsyncEnumerable, you need to await and iterate the iteration. And again, I added some delay for processing time. And again, you need to yield the result using the yield keyword. So it will just return the list of IAsyncEnumerable user. Again, as you cannot return is as it is, you need to iterate at every level and return it using the yield keyword. So let's see how it works. So API has been loaded. Now we will request the data using a cancellation token. So now, as we are using IAsyncEnumerable, so it will return the result as soon as it receives from the backend. And in meanwhile, if I cancels the request, so it throws the exception at a database level, like the task was cancelled. So you can handle this exception through try catch block, or you can just log the exception for logging purpose. But the main purpose is like it didn't process any other further record after loading 12 users. Yeah, as soon as the user cancels the request at the browser level, it just sets that cancellation token and passes at database layer through and then cancels the request at the database level itself. So this is through this you can avoid the wastage of memory, So when you are working with a huge data set at a or the processing time to load the data from a database is used, where you're requesting a data from multiple tables, suppose 10-20 tables. So at that time, this cancellation token is very helpful. Again, so in this example, we saw that the cancellation token was used as a database side. So if in a given scenario, if loading of data from a database is not taking that much of amount of time, but your business processing those data at a business level is very high, like you have some complicated business logic. So to cancel the request at the backend processing, we can go with another approach. Like we can see there is a third API which handles the cancellation token in the business logic. So over here, the signature is again same. So we are using without the IAsyncEnumerable. So it is just a normal call. It is not a asynchronous call. So at a repository level, again it will load all 20 users at a time in a memory, and then in a business logic we are iterating all 20 users, and we are checking whether for each iteration the cancellation token was set by the front end or not. So as soon as in any iteration the cancellation token has been set, then we are throwing an exception, so we are not continuing with the further processing. And to add some time, we are just making that thread to sleep for a few seconds. Over here, we have just catching the exception through try catch block. And yeah, we can just give a try. So API has been loaded. Now we will see over here. So data has been loaded from a database, and it's being processed in our business logic. So it was not IAsyncEnumerable, so nothing has been displayed or yield. So as soon as we cancel this request, again it thrown an exception, because that token was set in some of the iteration after loading 13 user. That token was set, and it thrown the exception from over here. So this is how you can use a cancellation token wherever you want. If the processing time in the business logic is more, then you can use the cancellation token in the business logic. Or if you say your requests or the data loading from a database is taking much time, so you can just cancel that request at a database level. But using the to cancel at a database level, you need to make it as a asynchronous call with the help of IAsyncEnumerable, and then again you need to use this extension method. Without using this extension method, the with dot cancellation will not be available. So it is mandatory to use the IAsyncEnumerable in that case. So that's the advantage provided by IAsyncEnumerable, both to cancel the request at a database side and also make the data available to a user as soon as it has been loaded or processed in the backend. So it minimizes the waiting time for any user. So this example was through the web API. So can we use the cancellation token when we are developing an application or Windows application or console applications? So yes, because in the web API, we have a provision to pass the cancellation token through the browser or the front-end technologies like Angular or React or any other technologies. But how you will pass the cancellation token when you are working with a Windows application? So in such cases, you need to make a use of a cancellation token source. You need to create an object of a cancellation token source. And if you say like after a few milliseconds or after a few seconds, I need to cancel this request. So it provides the method called cancel after. So whatever time you define, suppose over here the 1 second has been defined. So after 1 second, the cancellation token will be set, and again you need to check whether that token was set or not in this way. So wherever you want to cancel the processing, you need to just check that token, and then you can throw the exception, or you can just terminate that request. So this is the one way how you can use the cancellation token in our console app. And the another way is like if you want to request some input from a user, like if he presses some key, then I need to cancel that request. In this example, again, we are making the use of a cancellation token source, and we are reading some key from the user. So suppose if he presses key C, then we will just cancel that request by calling the cancel method on the cancellation token source. And again, it will set the cancellation token. And again, you need to check whether that token was set or not through through this logic itself. So this is how you can cancel the ongoing request in the API or the or any Windows or the console app. So it is supported by both the at both the side. So yeah, this is how the cancellation token works with or without the IAsyncEnumerable. So these two topics are basically used to minimize the waiting time of an user, and also to avoid the huge memory allocation or memory uses whenever the request has been cancelled by an user in the front end. So yeah, this was the basically the use of an IAsyncEnumerable and the cancellation token. So if you have any queries or any doubts related to this, you can just comment in the comment section.
Thank you, Tejas. It was a really interesting talk. It was quite informative, and without wasting much time, let's move towards answering the audience queries. So we have one query from Kunj Patel, which says, will in IEnumerable works in case data coming via web API or services instead of directly from DB?
Yeah, I showed the example using the web API itself, but as I understand his question, like if he's asking, like, does that one API calls the another web API, third API? So in that case, also again, the third party API which you are using needs to support the IAsyncEnumerable. So that API also needs to pass the result in form of IAsyncEnumerable. Just like over here, the database layer passes the result in IAsyncEnumerable, and again, then whatever data you are getting from the third API, again you need to await and it reiterate each record, and then you can return it as soon as you receive one record in your application. So yeah, at multiple levels, the IAsyncEnumerable is supported. So, but yeah, you need to make the use of IAsyncEnumerable everywhere for that purpose.
Okay, thank you, Tejas. And one more question we have from audience is like how the performance is getting impacted. Let's say when you explain for IAsync enumerable, when you explain other approaches as compared to the IAsync enumerable.
Okay, so over here we looked for three approaches. One was a synchronous call, the second was using the yield keyword, and the third was the IAsyncEnumerable. So for the performance level, we can just compare. So if we load all 100 records for a synchronous call, then loading all 100 records through yield keyword, and then using IAsyncEnumerable. So yeah, we can just check. So from my point of view, there is no much performance differences. Like even in the IAsyncEnumerable, you are iterating all the result in each layer. For example, over here in the
Okay.
database layer, you iterated all the 100 records, and again when it passes to the API, again you need to reiterate all those records. But still, it doesn't add much performance delay.
Okay.
So if we see, like we are requesting the data through asynchronous call. Wait, I just added, need to remove delay time. Yes, we'll add 1 second for each record we have in API. No, that's it. So yeah, it took around 2 seconds to
Hmm.
load all 100 users.
Okay.
So now we make through yield keyword. Let me stop this one. So again, around it took 2 seconds or more than 2 seconds using a yield keyword. And when we request it through IAsyncEnumerable,
Okay.
why I need to just. So by looking at example, we might think like IAsyncEnumerable might be taking a longer time because it has been iterated in each layer. But yeah, we can check through this our demo. So it is just like same. It's again took around 2 seconds or more than 2 seconds, which was similar to the asynchronous call and yield keyword. But the advantage it provides, like it provides each record immediately to the user in the front end. So there is no much performance impact, even though it was iterated at each level. But yeah, it's giving you the other advantages also.
All right. Okay. Clear. Thank you, Tejas. And one more question we have from audience is like, is this IAsync enumerable supported by LinkU, or can it be used by with LinkU?
Yes, as it is supported at a database level, as you saw in the repository, like on the DB context, you are making calling it as a IAsyncEnumerable, and if you want to use a cancellation token, it also provide you provision or extension method with a cancellation. So similarly, it also provide the same functionality or the same features in the LinkU also, because the LinkU is also can be IEnumerable or iQueryable. So again, that also has the extension method to use the IAsyncEnumerable over there as well, with including the cancellation token. So even if you are processing your data or iterating your data through LinkU, it will provide you the same feature. So
Okay.
yeah.
Okay. Thank you, Tejas. All right. So I think we don't have any more questions. So I'll bring in James as well. So yeah, moving to an end of the meetup, I would like to request once again to provide us the valuable feedback. Feedback form link is already shared in the chat. I'm just highlighting it here as well. So I request everyone to provide us your valuable feedback. And I think we have one more point from. So it's a question for you, Tejas. Is
Okay.
cancellation token also useful in post requests?
Uh, I'm not tried, but uh, I don't think there will be a need. But yeah, again, if your request involves use database or processing time, but you can't guarantee like your database changes will be consistent. Like if you're requesting a post request for updating 5 tables, and if it is updated only two tables, and you then cancels that post request, so there is a high chances like your database will be inconsistent. Like you why you will need to cancel that request without updating the rest of 3 tables. So I don't think it is a good idea. first of all, I need to make sure whether it's supported by the post request or not. But
Okay.
I don't see any requirement for the post request. Like then there will be high chances of data inconsistency.
All right. Thank you, Tejas. I hope, Tamer, you got some hints and idea for your question. All right. So now let's move to an end. So I would like to thank the audience for attending this event, our speakers, James and Tejas, for sharing the knowledge effectively, and of course, our volunteers who were at the backstage helping us continuously to make this event successful. We wish to see you all back in the next edition of our Tech Meetup. So till the time, goodbye. Thank you, everyone.
Thank you.